Pre-Calculus 4.2, Day 1. We are going to be looking at a unit circle and evaluating trig functions using it. And then we are going to be evaluating some trig functions. And so first of all, a unit circle is a circle centered at the origin with a radius of 1. And so it's important to note when a problem says that you have a unit circle, because then you know the radius is 1. And so that's what we have here. We have let P, which is a point in the Cartesian coordinate system, where the terminal side of the angle, theta, meets the unit circle. So here's that terminal side, the point of intersection of that terminal side. And we're saying this is on the unit circle. So that means that automatically this hypotenuse is 1. And since this is x and this is y, then this length is 12/13. And if I were to drop a right angle, this height is the value of y, or 5/13. So it means I have a triangle where this is 1, this is 12/13, and this is 5/13. And so if I'm looking at that triangle, the sine of theta is this angle in here. It just, you couldn't quite get it scooted over in there, but it's that angle. That's where this theta is going, right there. It's that angle of rotation. And so sine of theta is that opposite over hypotenuse. And so if this is theta, the opposite is 5/13, but the hypotenuse is 1, so the sine is just 5/13. The cosine of theta is that adjacent over hypotenuse. Well, for that theta, the adjacent leg is 12/13, and the hypotenuse is 1. And so the cosine of theta is 12/13. And then for the tangent of theta, it is opposite over adjacent. And for that angle, the opposite leg is 5/13, and the adjacent leg is 12/13. And that simplifies, the 13s will end up canceling. It simplifies to 5/12. How does that work? Well, 5/13 divided by 12/13 is going to be 5/13 times the reciprocal. When you divide by a fraction, you multiply by the reciprocal, and those 13s cancel, and you get 5/12. And then they want all 6 trig functions, so then the reciprocal of sine is cosecant of theta, so that's going to be 13/5. And the reciprocal of cosine is secant of theta, so that's going to be 13/12. And the reciprocal of tangent is cotangent of theta, so that will be 12/5, because those are just reciprocals. Okay, so it's very important, unit circle, radius equals 1. And so because of that fact, when we have this point where the terminal side hits the unit circle, and that point is given the ordered pair xy, what always happens if I drop an altitude to the x-axis, and here is my angle of rotation, this side is x, this side is y, and the hypotenuse is 1. So the sine of theta is y over 1. It's always over 1, so the sine of theta is just your y coordinate. Cosine of theta is your adjacent over your hypotenuse, but since the hypotenuse is always 1, cosine of theta is just x when you are on the unit circle. I can't stress that enough. And then tangent of theta, in that triangle, the opposite leg is y, the adjacent leg is x. So tangent is your y coordinate of the point over x. And then cosecant is the reciprocal of sine, so 1 over y. Secant is the reciprocal of cosine, so 1 over x. Cotangent is the reciprocal of tangent, so cotangent is x over y. So that's going to help us evaluate trig functions on the unit circle, are those definitions. So this right here, xy, is really cosine of theta, comma, sine of theta. And we'll talk about that again a little bit later. All right, well, when I'm evaluating these, I need to look at what we call the reference angle. And you will see that in the book as theta prime. You also see it on a worksheet that we use as theta bar. And so both of those ways of notations are going to be what we use to ask for the reference angle. And the reference angle is always an acute angle. It is an angle between 0 and 90 degrees. It's always positive, and it's formed by the terminal side of an angle, it should be angle, in standard position, and the closest, nearest x-axis. So we'll show you that as we draw these. So determine the reference angle. Sketch the original angle theta. So we have a circle. And so we have the initial side. And 50 degrees is a little bit more than 45. And so this angle already is a positive acute angle. So theta, the reference angle, is itself because it's already an acute angle. When you get to 120 degrees, I'm not going to draw the whole entire circle. You're going to have your initial side here, and 120 is 2 sets of 60. It's 2 pi thirds. It ends here. And so this is your 120 degrees. That's not a positive acute angle. So it says the reference angle always uses the terminal side. So in this case, here is your terminal side and the nearest x-axis. Well, basically, you're going to be picking a point on that terminal side and thinking about dropping an altitude to that would be the nearest x-axis. And so that nearest next axis is this negative x-axis. And so theta prime is this angle right here. That is going to be theta prime. That is going to be your reference angle. And when you rotate 120 degrees, you're 60 degrees from that 180 degrees. So theta prime is going to be 60 degrees, a positive acute angle. So theta prime or theta bar. So once again, it is, oops. I can't seem to erase it, so I'm not going to. It is, I'm just going to use a different color. It's this angle right there of the triangle when you drop an altitude to the nearest x-axis, and it's an acute positive angle. All right, so in part C, 7 pi 6. You need to know how to draw that. It's a half a rotation plus an additional pi 6. So if I go to draw that, I have my initial side, and I'm rotating around to pi 6, which is taking and going 30 degrees beyond the 180. So pi plus pi 6 is about here. So this rotation, the full rotation, is 7 pi 6. But then if we thought about a unit circle and where that terminal side hits that circle, so we'll just say it's right there, I'm going to drop an altitude to the nearest x-axis, which in this case is going up to here. And so the angle formed by the terminal side and the nearest positive x-axis, the angle formed by that is your reference angle. And so my reference angle is this angle right in here. This is my theta prime, the angle formed by the terminal side and the closest x-axis. So if the full rotation was 7 pi 6, you've gone 1 pi 6 beyond a half a rotation. That angle is pi 6. And that is your reference angle. So in part D, 5 pi thirds, I think of it as 1 pi third short of 2 pi. If I had 6 pi thirds, it'd be 2 pi. So I'm pi thirds short of a full rotation. Or I can think of it as 3 pi thirds, which is a half of a turn, plus an additional 2 pi thirds. So when I'm thinking about rotating through this, I have my positive x-axis, and I'm going to go a half of a turn, that's 3 pi thirds, and then I have to think if I divided that second half of a rotation from pi to 2 pi into equal thirds, this would be one of those pi thirds, and then this rotation would be another pi third, and so I'm ending up about here. So this whole thing is 5 pi thirds. So the reference angle is the angle formed by the terminal side and the closest x-axis, which in this case is going to be this side. If I take a point on that terminal side and drop an altitude to the x-axis, it's going to look like this. And so that angle formed by the closest x-axis and the terminal side is this angle right here. So this is your theta prime. And so you have to figure out how far am I when I do a rotation of 5 pi thirds. What would it take to get to 2 pi? And it would take an additional 1 pi third to get a full rotation. So that angle measure is pi thirds. And so on this, don't give you credit if the angle's in radians if you give me the reference in degree. I don't give you credit if the angle's in degrees and you give it the reference angle in radians. You need to give that reference angle in the same format that theta is given it. So A and B have to give degrees as answers. C and D have to have a radian measure answers, or you will not get credit. So same thing with E, your end answer has to be in radian measure. And on this one, you're going to rotate clockwise because it's a negative angle. So a negative 3 pi force is not half a turn. If I think about dividing that half a turn in the negative direction into 4 equal parts, I'm going to rotate through 3 of those. So I'm going to end up here. So that angle, that rotation is a negative 3 pi force radians. And then I'm going to pick a point on the terminal side and drop an altitude to the closest x-axis, which is over here. And then the reference angle is the angle created by the terminal side and that closest x-axis. And so the reference angle on this is this angle right in here. This is theta prime. So you have to think, if I kept rotating, what would I need to rotate to get to that negative pi? And I need to rotate another pi force. And the thing is, yeah, to rotate it would be a negative rotation, but the reference angle is a positive acute angle. So theta prime is going to be positive pi force. It can't be negative. Reference angles are always positive acute angles. So we're going to be using those reference angles as we evaluate triangles. So the next thing is to evaluate these trig functions. And so we want to just kind of look at a couple of 45, 45, 90 triangles. On a 45, 45, 90, we've already talked about how if the whatever you do, when you go from the leg to the hypotenuse, you multiply by root 2. So one of those triangles we use is let the legs be 1 and let the hypotenuse be root 2. But on a unit circle, we want the hypotenuse to be 1. And so if the hypotenuse is 1, to get to the leg, you need to divide by root 2. So this side would be 1 divided by root 2, but then we rationalize, and the side is root 2 over 2. And the legs are equal, so we have root 2 over 2 for both of those. And so that's a handy triangle to use where the hypotenuse is 1, because if we're using the unit circle. Same thing with a 30, 60, 90. We have the short leg, we let be 1, you multiply by 2 to get to the hypotenuse, you multiply by root 3 to get the leg. But we want the hypotenuse on a unit circle to be 1. So we need to go backwards. To go from the hypotenuse to the short leg, you have to divide by 2. But then short leg to long leg, you multiply by root 3, and the long leg will be root 3 over 2. And that's a handy 30, 60, 90 triangle to use when we are looking at the unit circle. So we're going to use those, and this first triangle, if I drop an altitude, what I'm going to say that this angle here is 30 degrees. And so that angle in degrees is 30 degrees, and in radians, that would be a pi 6 rotation. So that's what those blanks are for. On the x-axis, it's 0 degrees or 0 radians. And since this angle would be 30 degrees and the hypotenuse is 1, here's our short leg, and this would be my long leg of root 3 over 2, using that 30, 60, 90 triangle where the hypotenuse is 1. So the ordered pair that's going to go with that xy ordered pair is, I'm going to the right, root 3 over 2, and I'm going up 1/2. And the power of this when it's the unit circle, as we saw back here, is that since sine is y and cosine is x when it's the unit circle, that ordered pair is cosine of theta, sine of theta, where you have this as theta. So what that means on this unit circle, since theta is 30 degrees and that point's root 3 over 2, that is saying this is the cosine of 30 degrees and this is the sine of 30 degrees. So if I know the unit circle, and I know when this rotation is 30 degrees, the ordered pair is root 3 over 2 and 1/2, I know the cosine of 30 degrees is root 3 over 2. I know that the sine of 30 degrees is 1/2. And that's the power of the unit circle. And that's why we want to know these ordered pairs on the unit circle. Likewise, if I have 0 degrees, since this is the unit circle, this point right here, you go to the right 1 and you don't go up at all. So this is a 1, 0. So I know the cosine of 0 degrees is 1, while the sine of 0 degrees is 0. It's the y-coordinate. Because these ordered pairs are cosine theta, sine theta when on the unit circle. All right, so we want to keep going with this. And I'm going to change these values because they're going to change up. The 0 degrees and 0 radians are part of it. I'm going to erase that. And the next thing that we come to is our 45, 45, 90 triangle. And so for this point right here, if the hypotenuse is 1, and if I drop an altitude to that positive x-axis, then this rotation right in here is 45 degrees. So it's 45 degrees, which is the same as pi fourths radians. And if I look at this triangle right here, if the hypotenuse is 1, both the legs are root 2 over 2. So this ordered pair for that place where the terminal side hits the unit circle is root 2 over 2, root 2 over 2. And so this is cosine of 45 degrees and sine of 45 degrees. And they both have the same value. Both cosine 45 and sine 45 degrees are root 2 over 2. All right, then we have where we have the 60-degree angle. And so if we have a 60-degree angle, I have, here's this place where it hits, the terminal side hits the positive x-axis. So I drop down an altitude, then this angle right here is 60 degrees. So it's 60 degrees, or it's the same as pi thirds. And I'm looking at this triangle right here. The hypotenuse is 1. The short leg is now here. That's 1/2. And this long leg is going to be root 3 over 2. And so this ordered pair is to the right 1/2 and up root 3 over 2. And so this is cosine of 60 degrees, sine of 60 degrees. Those are the values of them. I notice I erased by accident the pi 6 there. And then lastly, if you go straight up, that ordered pair is 0. And then you go up 1 because you're on the unit circle. That length is 1. Distance up is 1. And so that means that the cosine of 90 degrees is 0, and the sine of 0 degrees is 1. And so this is 90 degrees, or pi halves radians. So now we're going to be using these to get our angles in quadrant 2. In quadrant 2, if I rotate so that my terminal side goes to 2 pi thirds, if I drop an altitude, this reference angle is 60 degrees. So this will be my short leg, but I'm going to the left, so it'll be negative, and my long leg is root 3 over 2 because the hypotenuse is 1. So this ordered pair is negative 1/2 up root 3 over 2. And there I have the cosine of 2 pi thirds will be negative 1/2, and the sine of 2 pi thirds is going to be root 3 over 2. In quadrant 2, the ordered pairs are negative and then positive. So that is why cosine comes out negative, because it's adjacent, it's x, and x is negative in quadrant 2. But sine is positive because sine on the unit circle is the y coordinate, and y is positive in quadrant 2. All right, so then if we rotate around 45 degrees, or 135 degrees, so we rotate and we end up here. If I drop an altitude, I drop an altitude to the x-axis, this is 1. This is a reference angle of 45 degrees, or pi force. This leg is root 2 over 2, and this leg is root 2 over 2. However, when you go to the left, that's a negative root 2 over 2. So this ordered pair is negative root 2 over 2 and up root 2 over 2. So we now have cosine of 135 degrees, sine of 135 degrees. Cosine is negative root 2 over 2, and sine is positive root 2 over 2. And then likewise, if we rotate 150 degrees, we drop the altitude, you are 30 degrees. That's your reference angle. This is 1. You're going a negative root 3 over 2 to the left, and you're going up 1/2. And so this ordered pair on the unit circle is negative root 3 over 2 and up 1/2. And then if you go pi units, you're to the left 1 and not up or down any. So that's saying that the cosine of pi is negative 1, while the sine of pi is 0. And of course, in quadrant 1, these ordered pairs are going to be 1, 0. You're going long, which is root 3 over 2, and up short leg, 1/2. 45 is always nice because their absolute values are always the same, root 2 over 2. And for pi thirds, I'm thinking I'm going to the right, and then up, I'm going to the right a smaller amount, up a larger amount, so that pi thirds is to the right 1/2 and up root 3 over 2. And then straight up 90, you're not going to the right or left any, so it's 0, 1. All right, so then using those angles, it says evaluate the exact values and sketch the angle. And so there's really, I want you to be able to do this either way. You can go and sketch the angle. 150 degrees is going to initial side there, and you're going to be 30 degrees from 180. So that's your 150 degrees. And so if you have a point on the unit circle and drop an altitude, where this hypotenuse is 1, this reference angle is 30 degrees. Since it's 150 degrees, give the reference angle in degrees. And so using, this is your long leg, it's going to be a negative root 3 over 2 and then up 1/2. So this point, if it's on the unit circle, negative root 3 over 2 and up 1/2. The cosine of 150 degrees is your x-coordinate. It is a negative root 3 over 2. And since we're in quadrant 2 and cosine deals with x, I expect it to be negative. And if you just know the value of that ordered pair because you have this memorized, which you need to do, not be referring to a table, you need to just be able to write those out. You can go, well, where is 150 degrees? It's here. That's your rotation. What is the x-coordinate of that? Negative root 3 over 2. So cosine of 150 degrees is negative root 3 over 2. All right, sine of 5 pi force. Now we didn't complete all the way around on the unit circle, so we're going to go ahead and draw this. And 5 pi force is 1 pi fourth more than half a turn. So it's going to end right here. There's 4 pi force and then an additional pi force puts you right here. So that's where we end. And if I have a point on that where it would hit the unit circle, the hypotenuse would be 1, and the legs are root 2 over 2, but they're both going to be negative. So if this is a point on the unit circle, the coordinates would be negative root 2 over 2, comma, negative root 2 over 2. And your reference angle right in here, that reference angle, I'm not going to have room to write it in there, is pi force. It's 45 degrees beyond pi, or 180. So it's pi force beyond pi. And that is always positive. It's a reference angle. And since theta was in radians, you need to give your answer in radians. So if I kind of erase that, maybe. Oh, I didn't really want to erase all that, but oh well. So this right here is pi force, and that would be your reference angle. And so the sine is the y coordinate of that, and it is negative root 2 over 2. Or you can say on this triangle, this is adjacent, this is opposite, and this is hypotenuse. And sine is opposite over hypotenuse, but since the hypotenuse is 1, you get negative root 2 over 2 that way. Cosecant of 2 pi thirds. It did say draw that angle. I know 2 pi thirds is going to end in quadrant 2. It's 2 sets of 60, so it's this angle, and there is my 2 pi thirds. And so if I have a point where that hits the unit circle and I drop an altitude, then I know that this reference angle is pi thirds, because it would take one more pi third to get to pi. So there's my reference angle. And so if that's my reference angle, I have my short leg here, I have my long leg here, and my hypotenuse is 1. This corresponds with that negative 1/2 and up root 3 over 2. And now cosecant is the reciprocal of sine. So that cosecant is going to be 1 over the sine of 2 pi thirds. So it's going to be 1 over your y coordinate, so 1 over root 3 over 2. If you have 1 divided by root 3 over 2, you end up multiplying by 2 over root 3. And then you need to rationalize. And so multiply by root 3 over root 3, and you get 2 root 3 over 3. And that is your cosecant of 2 pi thirds. So cosecant's definition is going to be 1, which we saw earlier, 1 over y, because this is a reciprocal of sine. And if we went back to the beginning here, that's what we said cosecant is when you are on the unit circle. All right, and then tangent of 90 degrees. This is what we call a quadrantal angle, because it ends on one of the axes. So we go from here to here, and we end up right here. That's your 90 degrees. We are not going to be dropping an altitude. We're not going to be using a reference angle. That's how they're different. We just have to think, if this is a point where the terminal side hits the unit circle, that point is, you don't go to the right or left any, but you go up 1. And then tangent is defined to be y over x when you're on the unit circle. So that tangent of 90 degrees is going to be 1 over 0, and so it is undefined. And when you're at a quadrantal angle, there are no reference angles. Cosecant. Cosecant is the reciprocal of sine. So once again, it's going to be 1 over the y coordinate, or 1 over whatever you get for the sine of 5 pi 6. So when you're starting to recognize these, 5 pi 6 is going to end over here. There is my 5 pi 6. So if I have a point here on the unit circle, and my theta is going to be pi 6, my reference angle. Then here I'm going to the left, it's the long leg, negative root 3 over 2. I'm going up 1/2, so that order pair is negative root 3 over 2, and up 1/2. And so 1 over y is going to be 1 over 1/2, and when you divide by 1/2, you multiply by 2 over 1, so the value of that is 2, and it is positive because the y-coordinate is positive in quadrant 2. There you have it.